project is called Save Your Teeth, Rethink. My topic is on corrosion, and my project is about the American Dental Association, or the ADA, has warned people that too much soda could damage their teeth, particularly their tooth enamel. This corrosiveness of soda treatment only proves and supports ADA's position on the said issue. To conduct an experiment on this, I'm going to use different types of sodas and the pennies for each type to see which soda has the greatest effect and cleans the penny and the time it takes to do so. I chose this topic because I wanted to learn more about corrosion and how it connects to everyday life. My hypothesis is that if I change the type of soda, then the time it takes for the penny to corrode will differ, because each soda is composed of different chemicals which could corrode and have a greater effect or lesser effect on something. My independent variable is the type of soda. My dependent variable is how corrosive the soda is and how much it has an effect on the penny. Some variables are the amount of liquid on the cups. Another is the pennies that I'm using. All of them will be from the same year it was made. My control group is the penny that is soaking in the cup of distilled water, which will act neutral. My testable question is, how does the type of soda affect how long it takes to corrode a penny? Background. Pennies are made out of copper, and after a while, copper gets dull. This is because the copper in the pennies reacts with air to create copper oxide. Soda has phosphoric acid. Most colas have a pH of 2.5 to 3.5. The scale for pH is a way to determine how acidic something is. It goes from 0 to 14, and everything under 7 is acidic. This means that cola is quite acidic. When the copper oxide, the pennies, and the phosphoric acid, the cola, get together in the bath, the acid reacts with the copper oxide on the pennies and dissolves it. That's why the pennies get shiny. The materials I'll use for this experiment is a bottle of Coca-Cola, Pepsi, Dr. Pepper, Sprite, Mountain Dew, and distilled water, 24 plastic cups, 24 tarnished pennies, a journal, a measuring cup, and a marker to label. Procedure. Take the 6 plastic cups and pour each of the sodas and water in every cup with 7 centimeters full each. Label each cup according to the designated soda. Drop 1 tarnished penny for each of the cups. Then put a stopwatch running simultaneously when you drop the pennies in. The procedure continued. Every day, observe what happens to the pennies. You are allowed to take the pennies out for a short amount of time and then put it back in. Continue doing this until any of the pennies get clean, which is when you take it out. Record time and write down observations in notebook. Repeat this whole process 3 more times. Calculate the average for each soda and every trial you do. This is the data I collected. The water never really, it took more than 100 hours. My graph is as my results is that the average time it took for a tarnished penny to be corroded for each type of soda is as follows. For Coca-Cola, it took an average of 24 hours, and for Pepsi, it took an average of about 27 hours. For Dr. Pepper, it took an average of about 43 hours. For Sprite, it took an average about 73 hours. And for Mountain Dew, it took an average of 44 hours. And as I said earlier, the water did not really corrode, so there's no result for that. From the results, I learned that the soda is really corrosive, and as much as it corrodes the penny, it can corrode your teeth enamel too. I noticed that darker colored sodas corrode the penny faster than lighter colored sodas, and therefore my final conclusion is that darker colored sodas are really corrosive. My analysis and conclusion, for errors, there weren't any errors in my project. The only thing that was there was that the time wasn't that precise. And for future research, if I was going to do this experiment again, I would make sure the pennies had the very same amount of tarnish as well. I did not make sure for the experiment I did this time. And also I want to do more research on rusting because it's the opposite of corroding, and I want to expand my knowledge on